Hello, my name is Andrea and today we are going to talk about motion in two dimensions. The formulas that we are going to use are to calculate behavior and time. The first formula is about initial velocity x, it's equal to initial velocity times cosine of the angle. And the second one is initial velocity of y, it's equal to initial velocity times sine of the angle. Once we have the components ready, we can obtain position and velocity. For x position, we are going to use this formula that is initial velocity x times time. And the second one is y equal to j velocity initial times time plus 1/2 of gravity times time to the square. We have two objects. Let's call them balls. And they simply drop from a certain height, and one is thrown certain height and one that's thrown horizontally outwards. Also from horizontally outward. Also from the same height. And then the question is which ball hit the ground first? And then the ground should have been flat and not quite. The answer is that they will drop both hit the ground at the very same time. I know, this seems a little puzzling, because we should think that the one that travels vertically will arrive first. The reason why they hit the ground at the very same time is because the motion of the x direction and the motion in the y direction is the horizontal motion of the ball. In the certain motion are completely independent of the another. Notice, in the horizontal direction, there's no forces acting on the balls. So this ball, the first one, will stay stationary in the x direction, simply fall down. And the y direction, this ball won't throw out in the right same direction of velocity in the x direction. It will no longer feel a force in the x direction. And so the ball will simply maintain the same velocity in the horizontal direction and in the vertical direction. We keep in mind that on the motion of x, of course the horizontal force is independent of the vertical motion. I mean that this force doesn't matter what happened with the height and doesn't matter what happened with gravity. So the time in the air for any projectile, no matter what happened to it, it depends of the vertical velocity and in the vertical forces. I mean these ones, the height and the vertical forces, that in this case may be gravity. So on the left ball we have a force due to gravity, and on the right force we have a force due to gravity, so both balls feel the exact same force, assuming that they have some mass and they are their same mass, and so therefore they are being pulled on the accelerated downward. At the very same rate, you can see that the velocities in the y direction are the sum of the same of the time interval, and you can see that their forces, they will be hitting the ground on the very same time. We are going to learn that the time and the air for a ball number 1 is equal to the time in air for number 2. And we're going to use this formula. So that is really important. Later we can see more about this. So as we can see, the horizontal movement are no forces acting in that way of direction, no gravity, and we can simply say that the velocity in the x-axis is simply equal to the initial velocity, that in this case is 0. It doesn't change, so whatever the initial velocity will be, it will be maintained the same velocity throughout its entire movement, simply equal to the initial velocity by the time of the vertical motion only, or right to the vertical motion in the velocity in the y-axis is equal to the initial velocity in the y direction. So we're going to use these formulas that we saw before we initial this time. So we just can say that the acceleration for the projectile will be a course of acceleration due to gravity, and that's minus 9.8, that it's the gravity due.